All right, thank you, Wolfgang, and welcome everyone to the presentation. My name is Ricardo Martins for National Laboratory of Civil Engineering in Portugal, or LNEC. And this is a presentation regarding the integration of Worsica's thematic service in EOSC, the challenges and achievements. So this is a project LUNEC is developing in collaboration with a multidisciplinary team with LEAP from Portugal, Dance from Netherlands, and IFCA from the Spain. So in this presentation, I will do a brief introduction regarding the Worsica and their challenges, and I will provide you some information regarding the service architecture before and after EOSC synergy integration. And the choices we have done will be described in technical description. And then we conclude with some achievements with this transition and the future work. So to start off briefly, Worsica is a web service or a web portal that aims at integrating remote sensing for determination of water presence. So uses the main scope of this project is to generate water-related domain outputs for water domains by using processing from imagery from remote sensing. And that can be used for determination of flooded areas or determination of water leaks in irrigation networks. So this is a software, is a portal that is applied for researchers and other water domain people. And also Worsica will be an interoperable service that we will reuse and connect some work from other projects from LUNEC, such as the even now talked by João Rogério, the Open Coasts, the WADI, and Mosaic.pt. So let's see briefly what are the main products of the Worsica. So the main products of Worsica are the three. So all of them use the main base of processing imagery from remote sensing and applying some water indexes, but some of them will apply different methodologies for different purposes. So for coastline, it uses remote sensing, water indexes, and determines the digital elevation model for each line. Then we have the water bodies that will do the same procedure as a coastline detection, but it is only a very light one, which is just to determine the water bodies in inland areas. And finally, the water leak detections that take advantage of the work we have developed in the past with WADI. It will use the water indexes, and you will use other methodology for water leak detection. So this is, as I said, this will be a portal available online and accessible from anywhere or anytime. So you do not need to download it, install it on your computer and run it. So this will be a single portal that will be available for everyone by registration. So this is aimed at researchers in coastal engineering as well as water irrigation networks management. So how does it work? So the user configures the workflow, chooses the region of interest he wants to process, and selects image sets from the various sources and applies the download. Then the service starts downloading and process them and generate the final products. So how does the processing workflow works in Worsica? So in order to understand one of the main concerns of this project, we need to explain briefly the workflow. So after the user launches a job submission, a workflow to be processed, Worsica will be automatically start processing it. And in the first place, it will start by processing each image set input the user has chosen by downloading, then applying atmospheric correction, and then doing the resampling and crop. And you will do that for all the image set inputs. And after finishing that, it starts to merging the inputs. So why is it is needed the merging of the inputs? To understand that, we need to make to have a conscience that remote sensing requires, um, for each region of interest for the same day, there will have more than one image set. If that happens, we need to merge them. These images are obtained from different orbits, and to provide the correct output, we need to merge them. So that after that, we can move on to the generation of the remaining steps. So we need to regenerate the RGB, as you can see on the image on the top, bottom right. And then we applied some water indexes and filtering, and then we can generate the final outputs to the user. So regarding the architecture, Worsica was developed still locally before EOS Synergy. And we have a main challenge, which was to integrate this into a massive infrastructure. So our platform, Worsica platform, was not very well conceived. It was done in one component, a web portal, that included inside a front end, which was a Django portal, and then a backend that will interact the user requests and starts and sends them to the processing service and waits for their outputs. And meanwhile, the processing service receives the requests by the backend, starts processing them, and returns to the backend to be loaded to the raster layer. So this was not a very a suitable architecture to be deployed to the EOS Synergy, because everything was on a cloud. It was a critical point. It was not scalable, not portable. It doesn't use Dockers. Everything was very limited to be used for that. So in the Worsica, for the internalization of the service in EOSC, we have made some challenges. So the challenges, as we have saw, are the integration of the processing, such as problems with the network, with the download speeds and number of simultaneous downloads. Then we have the problem of the storage, because each input is very big, and during the processing, the intermediate and final outputs are being produced, and computation resources that are very demanding for this processing are required to speed up the image processing and to prevent bottlenecks on using this service. So, and finally, I forgot to mention this one. We need to assure in this integration the resilience and speed up of this processing. For the thematic service, we need to assure the scalability, redundancy, portability, and also the interoperability with other thematic service. Finally, we need to assure the data fairness for our user-generated products on this thematic service. So during the development, we have achieved the following architecture that suits the requests for integration of this EOSC synergy. So we have achieved this architecture, which is atomically composed by small components. So we have a front-end component, a web portal on the cloud. Then we have intermediate component, which was before the backend, but it will be even better backend. So we will be simple task orchestrator that receives the request from the front end and sends and then generates, organizes the tasks to be sent to the grid infrastructure, and the processing component that will be a Docker that can be sent to the grid infrastructure to start processing the products. So also we have splitted the various small components, the Dataverse, storage, broker, and the database into isolated components. The advantage of it is to provide redundancy, scalability, and flexibility, good weight distribution, and components, since are used in Dockers, are easy for portability and installation. So as I explained before, everything on the before was done locally and was very limited. So in the EOSC infrastructure and this initiative, it is required to use the available EOSC services, such as authenticated, federated authentication, EGI check-in, workload manager ArcCE with Slurm, I'm a research manager IAM with Tosca, data storage Nextcloud, monitoring Argo, and other all inputs from other open costs and the Dataverse, as well as computing resources and storage are from FedCloud. So the reasons for that, for these choices, are because for the authentication we use federated authentication, but for because it is a requirement to use available EOS services and resources. We use then the workload manager ArcCE for the same reason. We use we need it to allow the efficient management of the available grid resources from a federated EOSC service. So then we have the Nextcloud that is used for storing processed job submissions, data inputs and outputs, and Dataverse for data fairness. And then we have the Ansible for the deployment as Slurm and Kubernetes for the resilience of the service. And also we have made some CI/CD for optimization by using Jenkins and unitary functional tests. So with that, we can achieve the following conclusions. So we can win, Worsica can win by using the EOS infrastructure, by winning on the resilience and speed up of the grid infrastructure, scalability and redundancy, on the service, portability and deployment of the service and the components, federated access and support for since it is a requirement to use the available services of EOSC, and interoperability that is a requirement for the communication from or to other services. And also we can provide the fairness.
Ricardo.
But let me finish.
No, you still wanted to hand over to Slava, or because you're eating up all the time?
Okay. I will finish in 50 seconds. So the future work is to improve the existing water processing, interaction, interoperability, and continuous improvement of our IT service. Thank you.
Thank you very much. In this lack of time, I would just wanted to suggest to continue sharing. Slava, can you take over? And I'm sorry, I have to speed up a little because you're stopping people from joining the recreational session.
Can you see it?
Yes.
Yeah, okay, I will continue. I will try to be as quick as possible. So my name is Slava Tikhanov, and I'm from DANS, this institution from Netherlands, and I'm going to tell you something about Service QA and Dataverse. So first of all, if you don't know what Dataverse is, I really advise you to check this. And it's an open source project developed by AQSS of Harvard University. It has really long history from 2006. And this data repository has clear vision and roadmap. And it's accepting also contributions from other people from research communities, and it has very well developed architecture with a lot of APIs. And there is also application layer built around of Dataverse, and even more important that it has a strong community behind. So our institution, Dansk NV, is one of leading partners in Shock project to deliver production-ready Dataverse for all partners in EOSC. So it was first it was like that. Worsica had a Django application with extra components like Postgres database. So obviously data was missing global identifiers and stored in multiple places, and it was difficult to access it. So there is no metadata layer available, and data access not following the control vocabularies and other fair components. And now in new setup, it has integration with Dataverse. So Dataverse actually provides a repository solution that complies with FAIR principles. And also there is persistent identifiers that Dataverse can generate automatically, and associated metadata for data sets also available. And it uses data commons to allow the data sharing between teams and projects, and metadata by default associated with CC0 license. So integration of code with Dataverse was done by REST API, and this is really sustainable solution. And it's easy to maintain Worsica code in parallel with Dataverse code. And current RESTful Dataverse REST API is very complete and allows to perform different operations. And also there is possibility in the future to use Dataverse to share sensitive data. It's called data tags, and currently it's in development with framework. So how interoperability works in Worsica Dataverse integration? Most of variables in Worsica datasets can be linked to in Dataverse to appropriate ontologies, and it can increase interoperability and data fairness, of course. So variable names can be also included in dataset metadata in Portuguese, but with associated URI identifiers that link to control vocabularies. It doesn't matter. So if you'll search in Portuguese, it can be found in English or in German. And also standardized metadata fields can be available in linked open data cloud using machine-to-machine interfaces coming from Dataverse. So this is just example to give you impression how it looks like. There are some fields from Worsica that standardize, some cannot be standardized, like title or description. But for standardized fields, they can get links to ontologies. For example, in this case, it's Wikidata. So for example, subject, like computer and information science can be linked to a Wikidata entity, and the same for other fields. And in this example, it's for GIS, like for geographic coverage, for country, state, and city. It can be linked to GeoNames or Wikidata or Getty or another ontology. And Dataverse allows to do that. And currently, we are working on control vocabulary support that can provide a unified solution for any kind of ontology. Very important to understand how Dataverse actually integrated with SQA process. So we're using Selenium tests, and this framework allows to run Selenium inside of SQA pipeline. And if everything is fine, it will just give green light, and it will go to as part of framework. And this is just how it looks like. There's a process that developer pushes code to GitHub. And there is Jenkins pipeline that builds trigger and clones workspace, and all functional integration and other tests and fairness tests actually getting running. And if everything is fine, it will issue a digital badge according to the results. And SQA API triggers abbreviated workflow. And like I already said, if everything is fine, it will just create Docker image. It will push this new Docker image to container, and it will update Kubernetes deployment. So everything is automatic, and everything is just out of the box. So as final remarks, Dataverse allows to provide a fair data repository for thematic services, not only for Worsica, but for other EOSC synergy services. And it has open source license. It's Apache 2.0. And it allows to manage public and private data. Also, it's getting data commons for sharing along teams and projects. And of course, there are some limitations. So it requires time to learn how Dataverse works and how to connect Dataverse to any thematic service. And also some fees should be provided to dataset that actually produces persistent identifiers for our system. So thanks. And if you want to get more information, this is our website. Thank you very much.
Thank you very much, Slava, and in particular, thank you for running through your slides. And also, sorry to Giuseppe that we ignored your raised hand. So maybe you can contact